Hello, I'm Eric, and let's talk about engineering Starlink Mini. The difference between the success of an operation in hostile terrain and a logistical disaster is often measured in watts of power and milliseconds of latency. The moment conventional infrastructure disappears, connectivity stops being a convenient service and becomes a critical component of systems architecture that simply cannot afford to fail. The Starlink Mini should not be understood only as a mass-market device, but as a feat of miniaturization and radio frequency engineering. Achieving a phased array antenna of that size while maintaining a functional data transfer rate is a highly complex technical challenge. From my perspective as a program manager, the true technical feasibility of this hardware lies in its ability to integrate into low-power ecosystems. Allowing satellite connectivity to stop depending on noisy generators or heavy electrical systems and instead operate under USB-C power delivery standards. This transition to the USB-C PD standard changes the rules of the game in remote site logistics. The autonomy of a communication station can now be sustained with portable battery banks or compact solar arrays, eliminating multiple mechanical failure points and simplifying field deployment. However, as analysts, we must be pragmatic and observe the unavoidable physical limitations. Thermal management. In such a reduced chassis, heat dissipation when the device operates at full capacity under direct sunlight is a variable that could compromise link stability in the long term if passive mitigation measures are not implemented. Another determining factor is network management and user density. While the hardware is a well-executed piece of engineering, the low Earth orbit satellite architecture must manage traffic intelligently to avoid bottlenecks in high-demand areas. For a field operation, the strategic value is not in high-definition media consumption, but in the guarantee that telemetry, global positioning, and coordination communications remain uninterrupted. It is the basic safety link that ensures the chain of command and supply remains intact regardless of geography. When evaluating the system's viability, the hardware cost is disruptive, but the structure of mobility data plans remains the main financial challenge for large-scale deployments. Nevertheless, in mission-critical systems analysis, the cost of being disconnected will always far exceed the investment in bandwidth. The Starlink Mini is positioned as a resilient and compact piece of infrastructure, designed under a functional logic that prioritizes practical utility and portability over raw power, establishing itself as an essential redundancy tool for any environment where communication is the only available lifeline.